Hello, Algebra class. If you remember last Tuesday, March 10th, we learned about factoring trinomials, and your homework assignment was page 528, number 3 through 17 all. Please get that homework assignment out in front of you. Pause the video if you need to. I'm going to show you the answers to those problems. And again, you might want to freeze the screen, pause the video to correct your work. Once you are done correcting your work, the way you hand this in is take your cell phone, snap a picture of it, and upload it to the Google Classroom website, where you see the assignment will be due for page 528. Today we're going to start with what we already have been doing and kind of put a few things together. So today we're going to factor to solve quadratics. These are the steps. The first step is set the quadratic equal to 0. The second step is to factor the trinomial. And the third step is to use the zero product property, set each factor equal to 0 to solve. Now we've done all of these things previously, but we haven't put them all together. So let's start with the first example. If you start with the quadratic, x squared plus 3x is equal to 18. The first step would be to set this quadratic equal to 0. So we subtract the 18 over. The second step is to factor this trinomial. And if you remember, if the third term is a negative, then our two factors will have opposite signs. One will be a plus and one will be a minus. If you remember, we called those P and Q. And in order to have the last number negative, P and Q must be opposite signs. And then now we have to ask ourselves, what are two numbers that multiply to 18? But in this case, since they have different signs, we would find their difference is 3. So factors of 18 would be 18 and 1. They have a difference of 17. Or 9 and 2 have a difference of 7. Or 6 and 3, they have a difference of 3. So those are the two numbers that we want. In order to get a positive 3, we would make the 6 positive and the 3 negative. Note that if we were multiplying this out using FOIL, first would be x squared, outer negative 3x, inner positive 6x for a total of positive 3x, and last negative 18. Now we're ready for the third step. The zero product property says if the product of two numbers is equal to 0, then either the first factor equals 0 or the second factor equals 0. So we set each factor equal to 0, and then we solve these mini little equations here. So if x plus 6 is 0, that means that x is equal to negative 6. And if x minus 3 is equal to 0, x would equal positive 3. And I would suggest that you actually plug this number back in here to see that it works. Negative 6 quantity squared would be positive 36. Minus 18 is in fact equal to 18. Or if x equals 3, 3 squared is 9, plus 3 times 3 is another 9. 9 plus 9 equals 18. Also remember that quadratics are degree 2, and if you have a degree 2 equation, then we know by the fundamental theorem of algebra that we would have 2 answers, 2 roots, 2 zeros to that equation. All right, let's try another one. Here we have the quadratic s squared minus 2s is equal to 24. The first step set it equal to 0. The second step, factor. So again, we have opposite. One's going to be a plus, one's going to be a minus because this number here is negative. Now we want two numbers that multiply to 24 but have a difference of 2. So run through the factors of 24. 12 and 2 have a difference of 10. 8 and 3 have a difference of 5. Or 6 and 4. 6 and 4 are your two factors, multiply to 24, but have a difference of 2. If we want a negative 2, we would put the 6 here and the 4 here because that would add to negative 2. Now we'll apply the zero product property, set each factor equal to 0, and then solve these little mini equations, and we would get s equals negative 4 or s equals 6. Now just a note, when you snap a picture of your homework to turn it in, I want to see all of these steps. You have to show all of this work to get full credit. Now sometimes the way the question is asked is just a little bit different. These instructions are find the zeros of the function. Well, remember the zeros are the same as the solutions, which are the same of the roots. The zeros of a function graphically, remember how a quadratic graphs to a parabola? And the zeros would be right here, where that parabola crosses the x-axis. What's the value of y right here? Y is 0. So if it is shown, the function is shown in function notation, f of x is equal to x squared plus 10x minus 39. It's just another way of writing it. We follow the same steps. We set that quadratic equal to 0. If you don't like the 0 on the left, you can put it over here on the right. Now we're going to factor this trinomial. So we've got a minus sign here. That means we're going to have, again, opposite signs. We want two numbers that multiply to 39 and have a difference of 10. Feel free to pause if you want to think about it. But your two numbers are 13 and 3. And we want a positive 10, so it'll be a positive 13 and a negative 3. Remember, if you FOILed this, you would get this quadratic. If the product is equal to 0, the zero product property says each factor is equal to 0, and therefore x equals negative 13 and x equals 3. We will go on to study in the future, not so much today, but to give you a heads up. What does that mean? That means graphically, if we were going to graph this parabola, it would cross here at 3, and it would cross here at negative 13. And we don't know exactly how far down the vertex will be, but we do know we will be able to find that in just another day or two. All right, the last example that I'll show you is written like this. Solve x times a quantity x minus 15 is equal to negative 56. Don't let this throw you off. We have to write this as a quadratic. That means I'm going to use the distributive property to multiply this through. Then I'm going to set it equal to 0 and factor. So let's go ahead and do that. X times x is x squared. X times negative 15 is negative 15x. If I add the 56 over and set it equal to 0, now I note that this is a positive number, so both of my signs will be the same. And since this middle number is negative, that means they both are going to be negative. Because I want two numbers that multiply to a positive 56, but add up to a negative 15. Pause if you want to think about it, but those two numbers are 7 and 8. So now set each factor equal to 0. Solve those equations. And you are good to go. All right, I think that I will also try and find a Khan Academy video to link to this if anyone is still struggling with factoring. Here's your homework assignment. I will also list this on Google Classroom, and I will see you next time.